the start of section 3.3, quadratic functions. We're going to go for about 10 minutes and then we'll stop because the bell's going to ring. So, quadratic functions are parabolas. Every quadratic function is a parabola. And there are different ways of writing quadratic functions depending on which format you choose. They're all going to look the same regardless of what format that they are presented to you in. But we'll talk about the three different forms of a quadratic function, okay? Let's do this first. Notice the graph of a quadratic function can open either up or down, okay? That depends upon what?
Negative.
Negative or positive. If the x squared is negative or positive is going to depend on whether it's opening up or opening down, right? Now there could be a number in between those, right? There could be like negative 4x squared, but that's going to tell you whether it's up or down. The second one always has a vertex, which is either a maximum or a minimum, okay? So if it's opening up, it's going to have a minimum. If it's opening down, it's going to have a maximum, right? It's going to have a high point if it's going downward. If it's opening upward, it's going to have a minimum, okay? Which should just kind of make sense. That's like this. Here's my vertex. He's going down, so he has a maximum. Here's my vertex here, which is a minimum because he's going up, okay? And this one is going up again, so I have a minimum. Okay, so opening up, opening down. The two on the outside are opening up. This one is opening down, max and min, blah, blah, blah. All right, the third bullet point says always has exactly one y-intercept, okay? Now, how many x-intercepts can a quadratic function have? 2. At maximum, he has 2 x-intercepts. He could look like this, okay? Or you could have 1 where basically he's just touching, his vertex is touching the x-axis, or he could have none. But this bullet point says that he can only have one x or one y-intercept. What if he would have 2 y-intercepts? He'd be on a side and it wouldn't be a function anymore, right? Because the vertical line test wouldn't pass. So he would be, if he's on his side, he would actually be x equals y squared instead of y equals x squared. So that's what he would look like, all right? And then it says it can have 0, 1, or 2 x-intercepts. That's what I just talked about over here. Okay? But y-intercepts, he can only have 1 for that third bullet point. Okay? A parabola is symmetric about a line through the vertex called the axis of symmetry. So if I'm looking at each one of these, this is my axis of symmetry, axis of symmetry, axis of symmetry. It's the straight up and down vertical line that, like, I can fold my parabola over, okay? And that is dependent upon any horizontal translations that I have, okay? Just y equals x squared, the symmetry goes through the y-axis, basically. But if I shift him left and right, he's going to be, his axis of symmetry is going to be moved. All right, here are the 3 forms. We're not going to get into these too much because I'll show you these examples down below. But transformation form, I call this guy vertex form. Okay, change the name of that because I will call it vertex form. Okay, they call it transformation form. I call it vertex form because all of the other math books that you will have will call it vertex form. Hold on. There we go. They will call it transformation in the assignment, but I will call it vertex form. Yes. Possibly. Okay, polynomial form. I call this guy standard form. I call that guy standard form. Sorry. Standard form. Okay? And the bottom one, x-intercept form, I call this factored form. Factored form. Okay? Factored, because he's factored down. Okay? So let's like pick apart this just here real quick. Vertex form. If he's written in this form right here, like ax minus h squared plus k, your a is basically your stretch or compression. That's basically what a is telling me in that scenario. A is not terribly important, but the other 2 values, the negative h and the plus k, h comma k tells me where my vertex is. T-E-X, where my vertex is. That's why I call this vertex form. Because H and K tells me where my vertex is. If you think about this in transformation-wise, if I take a quadratic function, I do plus K to the end of it, that's moving it up K units. If I do minus H on the inside, that's moving it to the right H. Does that make sense? If H is already negative, that will be X plus whatever the H is, and that'll move it to the left. So HK tells you where your vertex is located, basically, because it's shifted left and right or up and down. All right? Standard form, I'm not going to talk about him very much. He is just ax squared plus bx plus c. That's what we see most of the time. Okay? And then this guy, you're real lucky if you get it to look like that, if he's already broken down for you, because then you can find the x-intercepts. That's why they call it x-intercept form. I just call it factored form because he's factored completely down. Okay? Let's do this first example and then we'll stop. Okay? So, this is transformation form. I call it vertex form. Vertex form, so the vertex is HK. The x-intercepts are where you set the y equal to 0. When we did in algebra, if you're trying to find the x-intercepts, which are like these points along here, all of those have a y coordinate of 0. So you're setting y equal to 0, or f of x equal to 0. Okay? So, in example 1, the transformation form, or vertex form they have, y equals 2 times x minus 3 squared minus 4. So let's figure out where the vertex is. If we look at H and K, what is the H going to be? Is it 3 or is it negative 3? It is actually 3. It is 3 because up here in the formula, it's minus H. Okay? So if there's already a negative there, he's a positive 3. Okay? We did this in calculus. You're right. And what's the K value? Is that one negative 4 or positive 4? That one you don't change the sign. It's negative 4. So I'm going to plot 3, negative 4. This guy right here. Okay? Now he's either going to open up or he's going to open down. How do you know which one?
Up or down.
How do you know whether he like does a smiley face or frowny face? How do you know? If it's positive or negative. This number out in front here, is he positive or negative? Positive, so he's going to open up. So I'm just going to put opens up. Okay? Now, this 2 that's right here tells me that he is vertically stretched. 2 equals vertical stretch. Okay? Normally when you have a parabola, you plug the very next one and it's just going to go like over 1, up 1, right? And then the very next point is over 2, up 4 because you're squaring it, right? So if I go 1 to the right, it's going to go 1 up. And then if I go 2 to the right, it's going to go 4 up. If I go 3 to the right, it's going to go 9 up from there, right? You see how this is going? Okay, now if I'm vertically stretching him, though, going 1 to the right is going to go 2 units up for my first point. Going 2 to the right is going to go not 4 units up, but 8 units up. Does that make sense? 2 squared is 4, but we're multiplying that by 2, which is 8. So he will be up here, 8 units above, whatever, like that. Okay? Exposure. Let me zoom in. Exposure. Is that better? Okay? 1 to the left is going to be 2 above, and then 2 to the left will be 8 above, so wherever that's at, maybe up there. I don't know. So he is skinnier than what a normal parabola is because he's vertically stretched out. Okay? That's what he will look like. Shoot, we didn't do x and y intercepts. Let's do that one and then we'll stop. X and y intercepts. Let's do the y intercept first. Y intercept first. To do the y intercept, y equals, I plug 0 in for x. So 0 minus 3 squared minus 4. Okay? Negative 3 squared is 9. 9 times 2 is 18 minus 4, which is 14. The y-intercept is 14, so it's going to touch up here at 14, wherever that is. Okay? Now to do the x-intercepts, I plug 0 in for y. This is a little bit more unpleasant. 0 in for y. 2 parentheses x minus 3 squared minus 4. Okay? How do I unravel that? What? No, I wouldn't for. No, I wouldn't distribute. Add 4. plus 4, plus 4. So 4 equals 2 times x minus 3 squared. Then what? Nope, not yet. Divide by 2. So 2 equals x minus 3 squared. What? Nope. Now square root. Square root of 2 doesn't come out nicely, right? But what is the square root of 2? Or how do we write the square root of 2? Plus or minus. Make sure you put plus or minus the square root of 2. Equals x minus 3. What? And then add the 3 over to the other side. So I do 3 plus and minus the square root of 2 equals x. Those are my x-intercepts. There are 2 of them, which is like at this decimal place and at this decimal place right here. Okay, good? We'll stop.